Okay, gang. So here we go. Metal finishes. Now, these are very different in comparison to timbers. So, I'm using examples of climbing equipment here. I don't really know why. I think it's because they're nice examples of anodizing and electroplating stuff. Okay, so the first and most boring types of finishing metals are using cellulose and acrylic paints. Now, often paint metals when they need painting. If, say, you've got a section of unfinished mild steel, for example, here. Now, a lot of the time, you can't just paint regular, like, I don't know, oxide paint or something straight onto the metal. You actually need to prime it first. So often what happens is you have to put on a layer of primer first before you put on what's called the top coat. So you put the primer on first, then after that, you can then put on, once you put on a number of layers of that, you can then put on the top coat on top of that there. And it's really because the metal just can't hold the paint particles. They just roll off. So you need almost like a sort of sticky primer layer underneath before the top coat is put on. Now that's what happens with cars. Cars are painted using a paint shop. I mean, they just have like powder coating, but they have to actually have either a special type of paint or they have to be primed first, and then they have the top coats put on. So primer, and then that leads on to what's called the top coat. Now with these kind of paints, you can get sort of effect ones. Like you can get sort of what we call, say, metallic finish paints. So these ones have a sort of like metallic-y sheen to them, or you can get what's called pearlescent. I think that's how you spell it. Pearlescent finish, and this is one that has a sort of a I don't know, it's got a slight sort of sparkle to it in a way, similar to the metallic one, but it just has a more of a sort of a bit like pearl. Pearl has a sort of you sort of see a range of colors in pearl. It's same with pearlescent finish. So these are typically what you get with cars. Cars will often come with the option of like metallic or pearlescent finish. So this is typically what's applied to cars. Now these kind of paints, they can be applied in many ways. They can be applied with spray cans, brush, or even like air gun, or airbrush, or even powder coating. So there's a range of ways of applying these. Okay, let's look at another one. Electroplating and anodizing. Anodizing is synonymous with, well, it can only really be done on a few types of metals. So aluminium works really nicely with anodizing. That's how you get these really sort of lustrous colors. And that's why I was showing the ice axe here. Like that's very much like a good example of anodizing there. They give very lush sort of deep, vivid colors. You get these lovely like reds and blues and oranges and greens and whatever, and like they really stand out. It's very eye-catching, the kind of colors you get with anodizing. So generally though, electroplating and anodizing work in very similar ways in terms of how they are actually applied. The really good thing is you get a very consistent thickness of finish. Unlike painting, manually painting with a spray can or something, where you're always going to get sort of thick areas and thin areas, electroplating gives an incredibly consistent finish or thickness of finish. If you just want like 1 or 2 microns over the top of it, it will give that everywhere, even around these tiny bits around the logo and stuff in here. It will be all the same. So the way it works is the metal part is put into a chemical bath, and depending on the color you want, it's a different types of chemical. And then you electrically charge the chemical bath, and then what will happen is the ions will flow to the cathode and then the parts or the anode. And then gradually these paint particles will build up on those parts, and then eventually it will give the color that you want. And you can remove it when it's reached a certain level of coating. Now, anodizing, like we said, this is to do with, think aluminium for this. Because oh man, I can't write today either. Have patience, please. It's the end of a long day. So yes, aluminium, that roughly looks like it says aluminium. So anodizing also has some other properties to aluminium. So what anodizing does actually is very clever. It gives a hard layer on the outside. So it makes the aluminium a little bit more resistant to scratches and bumps and knocks and things like that. But it also is an insulator, which is quite interesting. or electrical insulator, I should say. So it's kind of interesting. So if you have, so the actual anodized layer can't conduct electricity. So that's one thing to bear in mind with this. It's quite interesting. So the next one then, dip coating. This is a great example you can see here. Now, dip coating, there's many different types of dip coating. Sometimes it's used for tools, where if you've, say, got the handle of a tool here, I don't know, a pair of like wire cutters or something like that, and it goes up to the blade on one side of it there with the pivot there. Sometimes a cheap way of putting a grip over the top is to dip coat it. So you can dip coat it in a sort of polymer bath. And then what that does is it will put like a nice soft rubbery coating on the outside, and it will also color it. So it gives it a sort of like nice finish. And it makes it more comfortable to hold as well. So you can add like a sort of rubbery style grip for comfort and aesthetics as well. So that's that's a very it's a very effective and very inexpensive way of coating stuff, because it's literally, you dip the part in like a powder, and then you put it in the oven, and then the powder particles just start melting and bonding together. And when it cools down, you just have this rubbery surface that's colored, and it sticks directly onto the metal. So it's very durable, is dip coating. And it's sort of grippy, and it comes in a range of colors, and it's also an insulator. So again, if you've got a screwdriver that's going to be used on electrical items, it will protect you from any electrical current. Now, another method is like this here, which can be called zinc plating, or we also have like galvanizing. And these are both basically where you have a molten metal bath. Like you can see here, this is probably zinc in here, like a non-reactive metal. Or non-ferrous maybe, because you might have these structural sections of steel here which would rust and corrode. And so instead of making the whole parts out of zinc or aluminium, which would be too expensive or not strong enough, if you still want to make it from a ferrous metal, you can then dip coat it into zinc, or you can galvanize it. And then that will coat it in a very, very thin layer of, say, zinc, for example. And is a very cost-effective way of stopping something from rusting. And the good thing is with this, it gives a very even and comprehensive covering. Yeah, which is great. So again, unlike spraying with a spray can, it's very hard to get an even coating there. So dip coating, so it's similar to the electroplating, because you get a very, very uniform thickness being applied to it. Now, powder coating is sort of like in the old days when there was only spray coating. Spray cans are awful, because what will normally happen is if you've got say you've got a section of metal bar that you're spraying there. Now, what will normally happen with spraying is you'll be putting your spray can will be just literally just spraying like whatever acrylic paint or something onto it. Actually, let's use orange. You'll be spraying it onto the metal part, and what will happen is you'll get a very non-uniform paint buildup. It'll be kind of blobby, and you'll have thick parts and thinner parts, and it will start looking quite patchy, and then you get like paint beads that start running down, and then it starts like dripping off the bottom there, and it's really messy and no good. So a way around that is using powder coating. So if we've got this is a great example, is like aluminium bicycle frames. So yeah, it's sort of inexpensive bicycle frames, not carbon fiber. If you've got a bike frame like that, yeah. Once it's had all the parts welded and joined together and ground down, they can then they suspend it in a powder room chamber. And it's very clever, because what they then do is they actually use like positively charged like paint particles to then spray on, but then the actual part itself is negatively charged. So what happens is when the powder paint gun, which you can see there, when that sprays towards the part, all the paint particles are attracted to the part because they're oppositely charged. So the paint ends up really, really evenly coating the metal part there. So you don't get the same, like, you'd never really get powder coated parts that end up getting dripped, drippy amounts of paint coming off, and you don't get inconsistent surface thicknesses. It gives a very consistent level of thickness, and it comprehensively covers the part. And also, you don't have to spray it from all sorts of different directions. So say if we go back to the conventional spray can here, you'd have to spray it from literally all sides to get a universal covering to make sure that no air is left. Whereas with powder coating, because the paint particles will sort of come from here, then they'll like kind of go and wrap around the back and all the ways around the negative charged frame. You don't really need to keep moving around and painting it from all sides because it will just do it. You can also get very thick coats applied with powder coating, which gives a layer of like actual physical protection as well. Yeah, so it's a very efficient way of painting, and also there's very little waste from it because literally all of the paint particles get attracted to the part. Okay, so another one is like varnishing and sealants and preservatives and stuff. So yeah, so varnishing, this is sometimes you can actually put on like lacquers onto metals. Now sometimes non-ferrous metals, so ones like copper, aluminium, these still oxidize, right? So you still get like a layer of oxidization. Now some of these metals it doesn't matter, but with, say, copper, it does, because copper goes green instead of brown when it oxidizes. Now, this can be a problem. So what you can do with copper is you can actually apply a lacquer, which sort of counts as a varnish and a sealant. And what that does is it adds a layer of protection over the top, which stops the oxygen from actually reacting with the metal. So then the copper will stay brown the whole time, will stay copper colored the whole time. So the way that you need to apply this is, if you're doing it to copper, you need to polish the copper first, get rid of any, and clean it probably with alcohol or something. And then after that, so you get it really squeaky clean and polished, and then you spray on your lacquer after that. Yeah, so it's a really, really good way of preserving that lovely polished, like buffed finish you can get. And sealants are similar as well, but a sealant is often more of a sort of polymer base that will be sprayed or brushed onto a metal part. So these are really good for offering more sort of physical protection against like impacts from bumps and knocks and things like that. So physical protections against impact, because it adds a layer, a sort of slightly rubbery layer to the metal. Yeah, and then other ways as well are preservatives. You sometimes see on some metal products, they say like, oh, it's fingerproof resistant or something like that. And what that basically means is they've applied a sort of preservative onto the surface as part of the casting process that will resist, say, fingerprint, the grease you get from your fingers, or it will resist condensation or something, or it won't shed an oxidized layer. And that's kind of what you get with like things like the MacBook Pro and stuff, which is why, even though it's aluminium, if you rest your hand on there the whole time, your hand won't go black, which it normally would from raw aluminium. There's no reaction. So yes, we've talked about anodizing already, and and cathodic protection is pretty much the same as anodizing in the sense that it's using different types of chemical to apply a coating onto different types of metal, because all different types of metals like work in different ways in relation to like which chemicals they react to and that kind of thing. So it could be that you're trying to make a metal non-reactive to salt water, and so so you can either put a coating on it, or if you have, say, a boat, you can do what's called cathodic protections, where, say, if this is like you've got a metal, I don't know, boat hull sitting in the water like that, it's made from like a ferrous metal. Now, to stop that from rusting, what you can do is you can put what's called sacrificial blocks on the outside. So these blocks might be, I don't know, pure iron, for example. And so iron is a lot more active in terms of like attracting, say, salt particles and corrosion and stuff. So these will sit on the outside, and these will do all of the corroding in them, and therefore it will protect the rest of the metal body from corroding. So a little bit like how you would use a heat sink to pull heat away from the area that you need to stay cool. It's a way of protecting another area. So that's kind of what cathodic protection does. Yeah, it will sort of draw away the rusting and oxidization away from another part. Then these can just be removed, and then new ones put back on again once they've kind of rusted to a point where they can't take any more rust. Okay, so well done, guys. That's it on metals finishes.